I'll be discussing Chapter 12 titled Entropy. This is Unit 4 of the Chemistry A-Level course. So, what is a spontaneous reaction? It's a reaction that takes place without continuous intervention. What's entropy? The property of randomness or disorder and can be measured by 2 to the power of n, where n is the number of molecules. So, how does temperature affect entropy? As you increase the temperature, you increase the energy. And energy are in packets called quantas. So these quantas have more ways to distribute, thus more entropy, more disordered, more ways of distributing. So there's a very important fact I have to know. Spontaneous, how do you know if a reaction is spontaneous? You calculate the entropy change, and if it's a positive value, then it is spontaneous. So this is the beautiful equation that we have. The total entropy is equal to the delta S system plus the delta S surroundings. The delta S system can be given by the sum of products minus sum of reactions. Remember to include the coefficients. So if it's 2CO2, you multiply the CO2 value by 2. For the delta S system, if you have a solid reactants that are turning to gas or liquid, so the delta S system will be positive. That's because there's going to be more entropy as solids are more ordered and gas and liquids are more disordered, so they have a higher entropy. Moles. So if you have in the reactants 5 moles that became 12, so that's more moles, so it's more disordered, so that there'll be an increase in entropy, so the delta S system will be positive. The unit for that is in joules per kilojoule per mole. This delta S surrounding is given by the negative and enthalpy change over the temperature, and the temperature is in Kelvin. So if you don't remember how to convert Kelvin and Celsius, you add 273 to your Celsius value to get Kelvin. The delta enthalpy is usually given by formation. It's giving you the formation of the reaction and products, and to get that, you do the products minus the reactants to find the enthalpy change. So if a reaction is endothermic, it will be positive, so the overall will be negative. If it's exothermic, which has a negative sign, it will be positive because negative times negative is positive. Remember, make it into joules and Kelvin. Usually this will be given in kilojoules and converted to joules. As you see here, I'm like, if it's positive, it's uh, thermodynamically spontaneous. So what does thermodynamically spontaneous mean? So there are two terms you have to know, and you have to know the difference: thermodynamic stability and kinetic stability. Thermodynamic stability depends on the entropy. If it's positive, then it is feasible. And the kinetic stability depends mainly on the activation energy and on the rate. If it has a high activation energy, then it's kinetically stable, therefore it's not feasible. It's not you can't. So some reactions could be thermodynamically unstable, so they are thermodynamically spontaneous, but kinetically stable. So that means you need a high activation energy to start. So you need to supply it with heat, and then it will become a thermodynamically stable um, reaction. So we're talking about lattice energy or lattice enthalpy. They're interchangeable. So the definition is the energy change in one mole of an ionic compound from its ions in the gaseous state is formed. So the Na is an ion in the gaseous state plus the Cl anion will give us the NaCl solid. This is an exothermic process as there's bond formation. So it depends on the size of the ions and the charge. So if it has a higher charge, it's going to have more electrostatic. And if it's a smaller ion, smaller radius and stronger electrostatic force. So looking for a smaller cation and a smaller anion. Also, there's something that comes quite a lot. I've seen it in 6 markers. Let me just experimental versus theoretical lattice energy. So it the they assume that the ions are in contact with each other, that they're perfectly spherical, and the charge is evenly distributed for all ionic compounds. However, that is not the case. Due to polarization, they exhibit some covalent character, so it's not ionic. Polarization happens with a highly charged cation polarizes and distorts the electron cloud of an anion. Remember, we want a large ionic radius for the anion and a small ionic radius for the cation. But we want the radius for both of them, we want the charge for both of them to be as high as possible. So, we're going to talk about the standard enthalpy change of atomization. It's the enthalpy change when one mole of a gaseous atom is formed from its elements in the standard states. It's an endothermic process. and electron affinity, basically adding an electron to compound. So the energy change when each atom in one mole of atoms in the gaseous state gains an electron to form a negative one ion. So Cl in the gas will add an electron to become Cl minus gas. So it's an exothermic process for the first electron affinity, while an endothermic process for the second. The second is endothermic because it needs an energy to overcome the repulsion. Since it's a negatively charged ion, after the first one, adding an electron, like charge is repelled. So endothermic process requires energy. Next is the Born-Haber cycle, my favorite part. So how do you construct a Born-Haber cycle? You start with the elements. You start with the elements in their regular state. Down is delta F formation. The arrows, if it's down, it's an exothermic process. If it's going up, it's an endothermic process. So these are the elements. And for the formation, they form NaCl. That's a negative process. So we have to atomization. We're going to atomize. The whole process is we're going to atomize the ions, atomize the atoms, turn them into ions, and then use them for the lattice energy. So we're going to atomize the sodium, and then we are going to ionize the sodium. Just the first ionization. For calcium, they could be two. So we're going to have Na plus in the gaseous state. Remember to always add state symbols plus an electron plus half Cl2 in the gaseous state. Then we're going to atomize the Cl to Na plus an electron plus Cl in the gaseous state. The first electron affinity is exothermic. So we're going to add the electron here. So this will be a negative ion and this will be a positive ion. And the lattice energy, as we said, it's the formation from the ions in the gaseous state to the solid. So this will be the lattice energy. They could ask you, so the delta F formation is equal to everything else. When I go from here to here, is the same as going all through this circle and back to down. This could be very useful to find one of the ungivens. So the ionization of sodium could be not given, or that one of the variables not be given. Remember to times 2 if needed. So if this was 1 Cl, if this was over here, let's just say it was 1. So there will be 2 Cl atoms. This was 1. So there are 2 Cl atoms, so the atomization will be multiplied by 2, as well as the electron affinity, which also will be multiplied by 2. Just remember that. More about the enthalpy change of solution and the enthalpy change of hydration. What is the enthalpy change of solution? It's the enthalpy change when one mole of an ionic solid compound dissolves in water to form an infinitely dilute solution. So it becomes in the solid, it forms two aqueous ions. While the enthalpy change of hydration is the enthalpy change when one mole of an ion in a gaseous state is completely hydrated by water. So they have to be in the gaseous state and they become hydrated by water. So as you see, this is the sodium, which is positive, it attracts the negative oxygen, and this is the chlorine attracts the um, positive hydrogen, partially positive hydrogen. Remember, this angle is 180. The angle is 180. This has a dipole, ion dipole interaction, where this has dipole interaction and hydrogen bonds. It's an exothermic process, and yeah, that's it. The next part talks about the ionic solution, delta H solution. It's the process of dissolving one mole of solute completely in water. So as you see, the KCl, which is a solid, becomes ions in the aqueous state. It requires two processes: breakdown of the ionic lattice, which is an endothermic process since you're breaking the bond, so it's negative lattice energy, and the hydration by water molecules, which is an exothermic process. The hydration is the metal and the non-metal. That's the delta H solution. This is the formula you need to know. So this depends. So we don't know the delta H solution if it's exothermic or endothermic. We'd have to know by calculating. This is an endothermic process, but this is an exothermic process. So this is the cycle that you can go. So you start with the most. This is how I like to do it. So if you have like a graph, and this is the highest entropy is the gas. So the gas as ions, and they form the solid as lattice energy. Delta solution is when they form an ions in the aqueous state, and hydration is when like they become aqueous, right? So aqueous. So this is the cycle. You could be asked to calculate an ungiven, and you maybe have to construct it. So I'd advise knowing it, and always remember to include the charge and the state symbol. More about enthalpy change of solution and the enthalpy change of hydration. What is the enthalpy change of solution? It's the enthalpy change when one mole of an ionic solid compound dissolves in water to form an infinitely dilute solution. So it becomes in the solid, it forms two aqueous ions. While the enthalpy change of hydration is the enthalpy change when one mole of an ion in a gaseous state is completely hydrated by water. So they have to be in the gaseous state and they become hydrated by water. So as you see, this is the sodium, which is positive, it attracts the negative oxygen, and this is the chlorine attracts the um, positive hydrogen, partially positive hydrogen. Remember, this angle is 180. The angle is 180. This has a dipole, ion-dipole interaction, where this has dipole interaction and hydrogen bonds. It's an exothermic process, and yeah, that's it.